Hello there, Mr. Chen here for Algebra 1. About to start a new section. Grab your student companion, note takers, turn to page 145. We're going to do some multiplying polynomials again, but this time it's 7-3 multiplying special cases. Let me know if you guys have any questions so far, but here we go. Let's get going, huh? All right. Opener, the table gives values for x and y and different expressions. We're going to be seeing what happens when we multiply certain binomials together. We have 3 rows of functions. They give us some x's and y's to try and plug in and see what happens when we try to plug it in to each of those, okay? So we have x minus y times x plus y in the third column. Let's plug that in, right? 7 minus 4 and 7 plus 4. And interesting, 7 minus 4 is 3, and 7 plus 4 is 11. Interesting. Three times 11 is 33. Okay, we'll keep that in mind. What if we were to square the 7 instead, and we square the 4 instead, and we went ahead and subtracted those numbers? 7 squared is 49, 4 squared is 16. What happens if we subtract 49 and 16? We get 33. Oh, that's interesting. That number is found by multiplying 3 and 11 over there. So they're trying to prove to you that those two things are the same thing. Does it work for the other pairs of numbers? Let's try it. 6 minus 2, 6 plus 2. Now 6 minus 2 is 4, and 6 plus 2 is 8. Interesting. What if we just squared the numbers? 6 squared and 2 squared. 6 squared is 36. Let's go and subtract them. 2 squared is 4. 36 minus 4 is 32. Aha! Look at that. 4 times 8 is 32. That works too. Isn't that weird? Very strange. How about the last row here? We have 3 minus 9 versus 3 plus 9. 3 squared and 9 squared. 3 squared is 9 minus 9 squared is 81. 9 minus 81 is negative 72. Over here, 3 minus 9 was negative 6. And over here, 3 plus 9 is 12. Let's see, negative 6 times 12. Oh, it is also negative 72. Isn't that weird? So we just completed the table there. There is a connection, ladies and gentlemen, between x minus y times x plus y, and that gives you the connection to x squared minus y squared. Isn't that weird? In fact, we use numbers to show that connection. What if we use actual variables? So, let's go to C and describe a pattern. This is what this section is all about, looking for patterns that we notice. When we take x minus y and multiply it with x plus y, this is what happens when we FOIL this. Let's do this. First terms, x squared. Outer terms, x times y is plus xy. Inner terms, negative y times x is negative xy. And finally, last terms, negative y times positive y is minus y squared. Notice what happens to the inner and the outer terms. They go away. The outer and inner terms cancel. That's what happens. This, ladies and gentlemen, is called the product of a sum and difference. Oh, by the way, this equals to x squared minus y squared. This is one of the famous patterns in algebra. we came from something called a product of a sum and difference. Let me write that down. This is a product of a sum and difference. You guys see the sum? There's a sum, and here's the difference. When we multiply them together, what do we get? This other thing over here. There's a name for that one. Write this down. Hold on. Product of a sum and difference. This thing over here, this result has a name to it too. This is called the difference of perfect squares. Difference of perfect squares. So you guys see the difference, meaning that there is a minus sign. See the minus sign right there? And each of the terms are square rootable. All right. Now, a typical one that you might see in the future might be something like this. Oh, 9x squared minus 25. Okay. Another one you might see as a difference of perfect squares. How about, I don't know, w squared y squared minus 81. That works. Z squared. All these perfect squares. Those are called difference of squares there. When you see that, that means it has a special pattern from where it came from. You can multiply together. X minus y times x plus y. Okay? So let's pick something up here with the use of structure. We have 7p and 4q. Try substituting variable expressions of the form 7p and 4q for x and y. So let's do that from above. X minus y times x plus y. So this was originally x and y, x and y. We'll put in the 7p and 4q. 7p, 4q. Okay? When you FOIL it or you multiply, you don't have to worry about doing all four products. You just do the first and the last terms. When you do this FOIL, the O and the I, meaning the outer and the inner terms, go away. You don't have to do all four products. You have to do the first terms. That's easy. Right there. 7p times 7p is 49p squared minus the last terms. 4q times 4q is 16q squared. Ding, 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 ding. You can skip the inner and the outers. That's it. So we get certain patterns when we multiply certain types of polynomials, binomials in this case. Here it was a product of a sum and difference, a negative and a positive, right? All right. Let's skip the habits of mind at the bottom. Let's jump to the next page. All right. Let's try this one. So the opener was a product of a negative and a positive. Here, number 1a, be careful before you jump into like thoughts here when it comes to, oh, I know what to do here. Be careful with number 1a. Don't do this. 3x minus 4, the whole thing squared, is not the same as this. 3x squared minus 4 squared. It is not that, okay? Because this is a binomial, you have to expand and FOIL. This is different, okay, from the previous one, okay? This is different from the opener. 3x minus 4 gets expanded, and you need to FOIL it manually times itself. Okay, here we go. Let's FOIL. I mean, you can throw it in a box if you'd like to. It's actually kind of preferred by a lot of people. I'll do it both ways. All right, first terms. Woo! 3x times 3x is 9x squared. Nice. Outer terms are next. Whoa! 3x times negative 4 is minus 12x. Inner terms are next. Woo! Negative 4 times 3x is negative 12x. And last term, of course, negative 4 times negative 4, be careful, is positive 16. So we have the situation where the middle two terms do add together. So be careful there. We get 9x squared. Negative 12 plus negative 12 is negative 24x plus 16. This is the answer. In fact, this particular thing that we've created is called a perfect square trinomial. Psst, as I say, this is a perfect square trinomial. You don't have to really learn to know about that by in this section. We'll talk about it more in the latter half of this chapter. So, what's the point? The point is that there's a pattern with the answer that we just got. 9x squared is literally 3x times 3x. 16 is literally negative 4 times negative 4 squared. Okay, that's the front half and the back half. The middle is literally the individual terms, 3x times negative 4 doubled. So 2, which is the double, times 3 is 6, times negative 4 is negative 24. That's the pattern. Is it the end of the world that you don't memorize these patterns? No. But here are what you'll get with a binomial times itself. Let me write it out. Generically, a plus b squared or a minus b squared when you expand and FOIL. Whoops. You get a pattern. Again, it's not the end of the world when you do this. So you know what it equals to? A squared plus 2ab plus b squared. Here this equals to a squared minus 2ab plus b squared. So it's kind of interesting how these form certain patterns. See how close they are to each other? Is it the end of the world that you don't memorize this? No. But those things that you created, a squared plus 2ab plus b squared, those are perfect square trinomials when you square a binomial. Okay, square binomial that's positive or negative. All right. 71 squared is kind of interesting. How does that fit with this square of a binomial? Well, here's what they want you to think. Think of 71 squared as 70 plus 1, like that. They pick numbers that are near 71 that are easy to just do in your head. 70 plus 1 squared should fit the pattern of, and I'm going to borrow this up here. Okay, 70 is A. The 1 is B. So I'm just going to use the pattern over here. So this equals to a squared plus 2ab plus b squared. That's what I'm going to do up here, okay? A squared plus 2ab plus b squared. I'm just going to put the numbers in. They are 70, 71, and 1. And you can manually just solve it. 70 squared is 4,900 plus 2 times 70 times 1 is 140 plus 1 squared is 1. And there it is. Add them up. Let's bring these over. 140 and 1. And I get 5,041. In fact, that is what 71 squared is. 5,040. It's like a shortcut. Is it the end of the world that you don't know how to do this? No, no, of course not. All right. So that takes care of the square of a binomial, whether it's positive or negative, right? This is positive, and this one's negative or minus sign. All right. Those are the patterns. Hey, this was part of the opener. Find the product of a sum and difference. Here's the pattern. Dun, 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 dun. If you have a plus b times a minus b, this equals to difference of perfect squares, a squared minus b squared. Yay, this is my favorite one of all time. Memorize that, definitely. Woo! So here, this is where you ignore the O and the I when you FOIL. This is from the opener, last page. Here, when I have a product of a sum and difference, I have a minus sign and a positive sign there. I can just do the first terms. 2x times 2x is 4x squared minus 4 times 4 is 16, and you're done. This is the pattern. A is 2x. B is 4. All you have to do is put it into this template or form to get your answer. That's it. Ooh, this is a weird one. I saw this 2 years ago and I go, what the heck's going on? 56 and 44? Well, they basically found out where 56 and 44 are nearest to a nearest 10 number, and that number is 50. So this makes sense now. So this is 50 plus 6, and this is 50 minus 6. And that's where they got that. They go, oh, that makes sense. Ha, ha, ha. You're breaking it apart. All right, we're going to FOIL this. A is 50. B is 6. We're going to use a pattern up here. And this becomes a squared minus b squared. So let's just put it in there. A squared minus b squared. A is 50. B is 6. That's it. We just clean that up and we're done. 50 times 50 is 2,500. And 6 is, I want to put it down here, 36. And when we subtract it, we get 2464. Yes. So that's an interesting way of approaching these problems. Yay. We're going to skip the bottom here. Let's jump to the next page. All right. Ooh. I'm going to set this up and not actually finish the whole thing. Or maybe I will. I don't know. Number 3. What is the area of the square image of the area of the border is 704 square pixels, and it is 4 pixels wide. Now they're referring to a picture in a picture frame. Okay, so that's what they're referring to. It's square though. They tell you the width is 4 inches wide, 4 pixels wide. Could be something on a screen. Okay, great. And they tell you the area of the frame is 704 pixels. Fine. Great. Square pixels. Question. What is the area of the square image? We don't know what that is, so let's assign it a variable, x and x. All right. So what we can do is basically figure out what the heck x is by that piece of information. Okay. So let's go ahead and figure out the width and the other width as well. You guys agree that I'm adding 4 to each side, and so isn't that x plus 4 for both the length and the width, based off of the distance around the frame? Yeah. And isn't area of a square length times width? That's what it is. Or side squared. Our area is 704. Let's put that in. 704. Nice. And our sides are x plus 4 is x plus 8. And we do it twice. Okay, so that's kind of interesting. Let's go ahead and, oh yeah. They tell, oh, I'm sorry. The area of the frame is 704, not the whole thing. So we got to subtract away the actual picture. We'll take that away too. Whoops. So that little guy inside there is minus x squared. This is the actual picture. I'm going to take that away. Interesting. Let's go ahead and FOIL that. Let's do the product of that sum. And so we'll get there. A little complicated, isn't it? Yeah. X times x is x squared. X times 8 is plus 8x. I could use that pattern, that product of a sum pattern. I could have done that, I guess. Ooh, look at this. See the x squares, everybody? They go away. X squared minus x squared goes away. Neat. That leaves me with a 704 equals to 8x plus 8x is 16x plus 16. The rest is undoing operations, solving for x. Subtract 16 to both sides. 16x equals to, what is that? 688. Interesting. What was that, 640? What? Oh, I did make a, oh, I see a little mistake, everybody. Whoops, caught myself. 8 times 8 is not 16. That should be 64. Sorry about that. Aren't you glad I caught myself there? Whoops. So that's a 64. Let's subtract 64 to both sides. Woo, caught myself. 704 minus 64 is 640. And divide by 16. Break out your calculator. 640 divided by 16 is 40 pixels. Very nice. Woohoo! X is 40 pixels. Now, we haven't answered the question yet. The answer is not 40. We got to literally plug the number 40 into my original picture right there. 40 goes into that equation right there. 40 times 40. 40 squared is 1,600 pixels squares. Square pixels. Yay, there's your answer. You guys ready for the last page? We'll skip the habits of mind at the bottom. Woo. All right, last page. I'm gonna do a lot of foiling. We'll use a pattern. I don't really care. Oh, here we go. Let's do it. All right. X minus 7 squared. Be careful. Don't apply the square inside the binomial. You have to expand and FOIL. Now, you can use a pattern if you want to. I don't care. It's up to you guys. But in this case, A minus B times A minus B is A squared minus 2AB plus B squared. That's the pattern for this particular problem. And you can put it in if you want to, or you can FOIL it. I don't really care. But here's the pattern. A squared minus 2AB plus B squared. Okay. A in this case is X. B is 7. Plug those numbers in. X, 7, 7, and simplify. X squared minus, 2 times X times 7 is 14X, and 7 squared is 49. Ding, 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 ding. There's my, actually it's a PST, right? Perfect square trinomial. Next one, we have our sum. Okay, let's write that formula down. A plus B times A plus B is basically the same thing, but with a plus sign everywhere. Guys see the pattern? All right, in this case, our A is 2X, our B is 5. Plug it into that pattern. I'm using this pattern right there, ladies and gentlemen. This is A squared plus 2AB plus B squared. Plug the numbers in. A is 2X, B is 5. It's kind of cool to have these patterns if you have them handy. 2x squared is 2x times 2x is 4x squared. Be careful there. Plus the middle product there. 2 times 2 is 4 times 5 is 20x. And then 5 times 5 is 25. Yes. Pause the video if you need to take a look. Ooh, the third one's my favorite. So the first one was a product of a difference. Product of a difference. I just want to make sure you all know that. Second one was a product of sums. And the third one is a product of a sum and difference. And that formula is A plus B times A minus B equals A squared minus B squared. The most famous one of all, you just have to do the FOIL part. So that's it. A squared minus B squared. A is X. B is 4. Plug them in and clean it up. X squared minus 16. No way. That easy? Yes. Woo! Oh yeah, number 8's the same. Yay. Product of a sum and difference. So you see a minus and plus sign there. X squared minus, A squared minus B squared. A is 3y. And B is 5. Plug those in. Yay. And clean them up. 3y times 3y is 9y squared. And 5 squared is 25. That wasn't that bad. Come on. Well, I'm actually going to skip the last two. Thank you for hanging in there and ask questions if you're concerned or confused. Thank you very much. Have a good day. Bye-bye.